Okay, so in this video, we're going to look at some specific examples of using IUPAC nomenclature on alkanes, and we are going to start with this example. So refer back to your 4 steps for naming alkanes. The first thing that we have to do is find the longest chain of carbon atoms, and that's going to be our parent chain. Now our eyes are trained to just look at left to right, 1, 2, 3, 4, 5, 6. But in this molecule, the longest carbon chain is actually here, 1, 2, 3, 4, 5, 6, 7. Sneaky. So now that we have found our longest carbon chain, this guy, that's step 1. Step 2 is to identify and name the substituents. So our substituent on this molecule is this guy right here, a 1 carbon chain. This substituent's name is methyl. You need to memorize the names of all of the alkyl substituents. You can find them in your book in table 4.2, which is on page 143. And I'm also going to have a set of flashcards for you guys in your folders on Tuesday that will have the substituents' names on them. So back to our steps. Step number 3 is to number the carbon atoms in our parent chain to give the substituent the lowest possible number. We only have 1 substituent. We want to give it the lowest possible number. So this numbering the chain, we're going to go from left to right or right to left, 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, whichever gives the methyl, whichever puts the methyl on the lowest numbered carbon atom. In this particular example, we want to number from right to left so that the methyl is on carbon number 3 and not on carbon number 5. Step 4 is to alphabetize the substituents. That doesn't apply to this example because we only have 1 substituent, so we don't need to worry about alphabetizing it. And the last thing, it's not really a step, is to put it all together to make the name of the molecule. So to assemble it all together, the very first thing that we do is locate and name the substituents. We have a methyl group on carbon number 3, so we say 3-methyl. That means on carbon number 3 there's a methyl. And then we name the parent chain, a 7-carbon chain, which is heptane. In addition to memorizing the names of the substituents, as you can probably imagine, you also need to memorize the names of parent chains with carbon atoms from 1 to 10 long. This is in table 4.1 on page 141. And again, you'll have flashcards in your folders for that, or you can make your own. In the name, the IUPAC name, you can break it all down. We have first the location of the substituent. Then we have the substituent. And then we have the parent chain. And this is the formula that we always use in all of the names, since this is why it's a systematic method. Where is it located? What is it? And what is it attached to? You always separate, in all IUPAC names, you always separate letters and numbers with a dash. So that's why we have a dash here, and in between letters and numbers there's a dash. So let's look at another example. This one's a little bit more interesting. Step 1 is to find the longest carbon chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It looks like we have a couple of ties for a 6-carbon chain. In the instance of a tie, remember we want to choose the carbon chain that has the most number of substituents. In this case, whether we use this as our longest carbon chain or this as our longest carbon chain, we're ending up with 2 substituents. So it doesn't really matter. Step 2, identify and name our substituents. This little 1-carbon substituent is methyl, just like in the last example. The 2-carbon substituent, 1, 2, is named ethyl. Some students, when they're naming these substituents, they get confused. They want to include this carbon as the substituent, so maybe they think of this as a 2-carbon substituent. Maybe they think of this one as a 3-carbon substituent. Don't do that. This carbon right here belongs to the parent chain. It's being counted down here in the parent chain. Don't make it a substituent, or don't try to include it with the substituents carbons. That's not fair. Everybody only gets counted once. Step 3, number the carbon atoms in the parent chain to give the substituents the lowest possible number. So if we go left to right, it's 1, 2, 3, 4, 5, 6. If we go right to left, it's 1, 2, 3, 4. So we want to number left to right so that our substituents are on number 3 instead of on number 4. Step 4, alphabetize the substituents. Ethyl comes alphabetically before methyl, so it will come first in the name. Remember, the first thing we do is locate the substituent. Ethyl is on carbon number 3, so we say 3-ethyl. And now we need to name the other substituent. It's on carbon number 3 also, so now we say 3-methyl. And remember that we separate numbers and letters with dashes, so that's why there's a dash in between ethyl and 3, and also in between ethyl and 3, and in between methyl and 3. And then last step is to name the parent chain, which is hexane, a 6-carbon chain. And again, if you're not sure how I'm coming up with the name hexane for a 6-carbon chain, go to table 4.1. And if you're not sure how I'm coming up with ethyl or methyl as the substituents names, take a look at table 4.2. This stuff you got to memorize. Let's do one more example on this video. Okay, so first job, find the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Looks like we have a 7-carbon chain tie. Remember, if there's a tie, we want to pick the chain with the most substituents. If we choose this, we have 1, 2, 3, 4 substituents. If we choose this, we have 1, 2, 3 substituents. So we're going to go with this as our parent chain. It's easy. The more substituents you have, the easier it is to name. That may seem counterintuitive, but trust me, it's easier. Next step is to name our substituents. Looks like we have 3 methyls on here. And we have a 3-carbon substituent, which is called propyl. Step 3 is to number our parent chain so that our substituents have the lowest possible number. If we go from left to right, our substituents are going to be on 3, 4, 5, 6. If we go right to left, they're going to be on 2, 3, 4, 5. So let's go right to left. And then our last step is to alphabetize the substituents. A, C, D, E, F, G, H, I, K, L, M comes before P. I seriously don't remember that. Thank goodness for the ABCs. I already forgot what comes first. Oh, methyl. Methyl comes first. So we're going to name the methyls. Now, in a case where you have more than one of the same substituent, like here, we have 3 methyls, you don't need to say 2-methyl, 3-methyl, 5-methyl. Instead, you say 2, 3, 5 trimethyl. We're saying on carbon 2 and 3 and 5, we have methyls. And then on carbon number 4 is our propyl group, and the whole entire thing is on a heptane. Notice that I used commas to separate the 2 from the 3 from the 5. That's convention. We always separate numbers from each other with a comma. And then if we can just dissect this name a little bit, we have 2, 3, 5 are the locations of tri, which is our prefix for 3 of these substituents. This tri is the Greek prefix. If I refer you back to step number 4 from the naming process, I told you if you're using a Greek prefix, you're going to ignore it during the alphabetization process. So trimethyl is alphabetized as M, not T. And if you don't remember the Greek prefixes, time to bring them back into your brain. You learned them at one point in Gen Chem. Di for 2, tri for 3, tetra for 4, penta, hexa. That's probably good enough. Now, in the next video, we're going to look at naming cycloalkanes.